Hey, grade eights. So this is take two because my computer just glitched before this and froze, but hopefully it doesn't this time. So we're on to chapter 11 on probability, last chapter of the year, and then we're done. So we have done probability in grade 7, so hopefully some of it is review. Let's just do a quick review that the formula for probability is equal to favorable outcomes, or the outcomes you're looking for, over or divided by your total outcomes, all your possible outcomes. There you go. Okay, so that's how you find probability. So you just find how many outcomes are there, what are the favorable ones, put it into a fraction. And right now we're going to do this, find these probabilities using tree diagrams and tables, which we did in grade 7. Hopefully this will be sort of review for you. Okay, so let's look at this case. The spinner is divided into 3 equal regions as shown. The spinner is spun twice. For each probability you determine, express answer as a fraction, decimal, and a percent. So 3 different ways of showing the same information, the same number, fraction, decimal, percent. We'll go over how to do that again. So what is the probability of spinning A on the first spin? Well, to spin an A, if you just were to spin this spinner once, there's 3 possible outcomes, A or B or B. One of those possible outcomes is A, and so you would have a 1 out of 3 chance of getting A on that first spin. Or you could write that 1 divided by 3 is 0.3 repeating. Or if you multiply that decimal by 100, you get the percentage, which is 33.3 repeating percent. Okay, so 3 different ways we can write it. B, draw a tree diagram to represent the sample space for both spins. So this tree diagram is when you start with your first event, and there's, in this case, there's the A you could get, or the B you could spin, or the other B that you could spin. Okay? Now, off of each of these events branches your second spin. So you could spin your A, and then after you spin the A, you could spin an A again, or you could spin the 1B, or you could spin the other B. Those are the 3 possible outcomes after you've spun an A. Or you could spin the 1B, and then spin the A, and then spin that same B, and then spin the other B. Or you could spin that last B, and then spin the A on your next one, then spin the B, and then spin a B. Because each of these, either of these events are independent, so the one event doesn't affect the possible outcomes in the next one. And so for each of those first outcomes, we have the same possible outcomes branching off. And so from here we can write our sample space. So it's just nice to write it in a list side. So you could get an A, then an A, or you could get an A, then a B, or you could get an A, then a B as well, that other B, or you could get a B, then an A, or a B and a B, or a B and a B, or you could get the B and the A, you could get a B, the other B, a B, and the same B. Okay, and then here is our sample space. Okay, so that would be draw the tree diagram to represent the sample space. So we showed the sample space, found it using the tree diagram. Okay, so for C, I'm just going to use the color red here. What is the probability of spinning A followed by B? So we show this with the notation P, comma, A, then B. So this is whenever you see this notation, just means what is the probability, that's what the P means, of whatever is in the bracket. So in this case, A, then B. So this doesn't say A and B, because that would mean any combination of B and A, but it's first A, then B. In this case, we have 1, 2 outcomes that are A, then B. So we'd have 2 out of 9, which you could, if you went 2 divided by 9, you get 2 divided by 9 is 0.2 repeating, which if you multiply by 100, is the same as 22.2 repeating percent. Okay, so all three of those are different ways you could have it written. So as a fraction, just as a decimal, or as your percentage. Yes, which colors again? Okay, so for D, what is the probability of getting the same letter on both spins? So probability of A and A, or probability of B than B. So probability of getting the same on both. So probability of the same letter. Well, A than A is the same letters. B than B, B than B, B than B, B than B. So in this case, there's 5 out of the possible 9 outcomes. So 5 divided by 9, neat thing we'll divide by 9, is equal to 0.5 repeating. 2 divided by 9 is 0.2 repeating. 5 divided by 9, 0.5 repeating, which is equal to 55.5%. So you just multiply your decimal by 100. So this 5 would be repeating. Multiply your decimal by 100 to find percentage. Okay, and that's that. So here's a tree diagram to find our sample space. Sample space is all the possible outcomes. Example 2, determine the probabilities from a table. So 2 standards, 6-sided dice are rolled. One die is blue, the other is red. Doesn't really matter what colors they are, it's to separate the two. For each probability, you determine express answer as a fraction decimal percent. So create a table to represent the sample space. Okay, so when you're making a table, along one side, along the top, you're going to have the one event. So we call this the blue dice. And the total possible outcomes from that one event. So you get a 1, a 2, a 3, a 4, a 5, or a 6 from the blue dice. So you get a blue die, or you could get the red die. Well, I mean the other event, sorry, is the red die, which you could get a 1, a 2, 3, a 4, a 5, or a 6. Okay, and so then once you have your 2 events listed on either side like that, you're going to want to separate. So I'll separate all of these ones with lines. Separate them all. 5 here. I can put one at the bottom of the 6 there. And then I'm also going to separate all of these ones, all the blue die outcomes like this. Okay. There we go. And now we have this table which we can fill in. So I'm going to try to fill it in pretty quick here. It can be a little bit monotonous filling these in, but if I was to show the red die always first, I could get a 1, a 1, a 1, a 1, a 1, or a 1, a 2 here, 2 here, 2 here. So going across from the red die, we get a 3 in each one of these outcomes, a 4, 4 here, 5s. Okay, so it takes a while to fill these tables out, but it is useful to be able to see the sample space, all the possible outcomes like this. Tables are quite useful that way. 6, 6, 6, 6, 6, 6, 6. Okay, and I'm just going to actually just make these lines a bit thicker to separate my single events from my sample space. Okay, and then my blue dice, I could have the red one with, above here, the blue one, or the red one with the blue 2, or red one with the blue 3, red one with the blue 4, red one with the blue 5, or a 1 and a 6. Or I could roll a red 2 and a blue 1, red 2 and a blue 2, red 2 and a blue 3, and so on, 2 and 5, 2 and 6. And so I'm able to see a 3 and a 1, a 3 and a 2. I'm able to see all of the possible outcomes very nice and neatly on this table. So when you have just 2 events, tables are very great to use. If you have more than 2 events, though, it doesn't really work. You need like a 3D table or something to show the third event. For sorry, I'm bad at talking and filling in the table. 5 and 6 and 6. Okay, so now we have all of our events listed here nicely. So A is done. We created our table and we showed the sample space. So what is the probability of rolling a sum that is greater than 10? I'm going to use purple here. So how many of these outcomes have a sum that is greater than 10? So I'm going to put a little dot beside each of the ones that do. So 6 plus 6, sum means addition. 6 plus 6 is 12. Okay, 5 plus 6 and 6 plus 5 is both 11. Now, this asks for greater than 10, so 10 doesn't count. And the next one we'd see would be 4 plus 6, which would be 10. 5 plus 5 is 10. 6 plus 4 is 10. So those aren't high enough. And then everything left of those are going to be less than 10. So for B, there were only 3 out of, well, how many outcomes are there? Well, we can count, but you know, there was 6, 12, 18, 24, 30, 36. 3 out of the 36 outcomes, which we could simplify, dividing each of those by 3 to 1 out of 12. And then you could divide that to find the decimal percent. I'm not going to do that right now. Okay, let's do green here. What is the probability that the number on the red die is 1 larger than the number on the blue die? So how many situations here is the red die 1 larger than the number on the blue die? So let's look. So 1 and 1 is larger. Okay, here 2 and 1, the red die is larger by 1. And now often on tables there's patterns, and actually if I move you know, to the right straight along here with 2 and 2, from then on the blue die is always the same or larger. Okay, so if I move down to the red die is 3, well 3 and 2 here, the red die is 1 larger. Okay, and 4 and 3, 5 and 4, 6 and 5. And those are all the ones where there's only a 1 number difference, with the red number being larger by 1. Okay, and so we get this nice straight line going across, and you'll often see in your tables, especially when you're dealing with 2 dice, there's patterns like this. So there were 5 outcomes of that kind. So there's 5 out of the 36. Okay, I wanted to turn that into a decimal. I would just go 5 divided by 36, and I get 0.138 repeating. I times that by 100, I would get 13.8 repeating percent. Okay, most of the time it's just going to be, we're just going to ask for fractions as your answer. Okay, one last, let's do yellow. What is the probability that the sum of the 2 numbers is less than 11? So the sum is less than 11. So it could be 10, the sum could be 10, so here's 6 plus 4, 5 plus 5, 4 plus 6. Those sums are all less than 11, and so are everything else. Everything left of each of these. So all of the remaining ones have a sum less than 11, because only 5 plus 6 and 6 plus 6 are 11 or greater. So we have all of these. Now I could go and count all of these, or I know that there's only these 3 outcomes in the corner here, because it's everything left of this line essentially is favorable. And so there's these 3 outcomes in the bottom right that are not favorable. The rest are favorable. So I can just take away those 3 out of the 36. And so I have 33 out of 36 are favorable, where the probability of the sum less than 11 so that's 33 out of 36. I can take my calculator. 33 divided by 36 is equal to 0.91 Okay, so probabilities as a decimal are always between 0 and 1, so they're always 0 point something, because you can't have a probability of less than 0% or a probability of more than 100%. And so there's the decimals are always in between here, so 0.9 is pretty high because times by 100 is 91.6%, and that is actually 6%. Okay, so that's how you make a table. Last one. Ellen flips a coin and rolls a four-sided die numbered 1, 2, 3, 4. What is the sample space? Use a tree diagram to show how you got your answer. Okay, so the first thing that could happen is she rolls a coin. She could get heads or tails. And if she flipped the heads, she could get 1, 2, 3, or 4. Or she could flip the tails and get 1, 2, 3, or 4. Just to be clear, it doesn't matter which way you put the two events since they're independent. So you could say she rolled the die 1, 2, 3, 4, and then flip the coin and got heads or tails or heads or tails or heads or tails or heads or tails. Doesn't really matter. Either one, you're going to get the same sample space. So now let's just write out the sample space. You can get a heads in a 1, a heads in a 2, a heads in a 3, a heads in a 4, or you could get a tails in a 1, tails in a 2, tails in a 3, tails in a 4. Great. Now what is B? What is the probability of getting heads, 4? So a heads and a 4. Well, there's only one of those out of the 8 possible outcomes. So the probability is 1 out of 8. Okay, here we have it. So key ideas, probability is equal to the number of favorable outcomes divided by the total number of possible outcomes. So this is our basic formula for probability. You always have to keep in mind. Probability of both A and B occurring is expressed as in the notation P, A, B. So that's just A and B with that comma. Probability of event A occurring followed by event B. So with A, B, it actually, the order doesn't matter. Just A and B together. Could be B and A, it's the same thing too. But event A occurring followed by event B is A, then B. Okay, so you have to look at that little language in there. Is it then, or is it a comma, or and? And you can use a tree diagram, which we showed, and tables, which are very useful to show the sample space. And then using that sample space from the tree diagram and tables, you can find the probabilities by counting the favorable outcomes, dividing by the total number of outcomes. Okay, and that's that probability. Hope that makes sense. There'll be no quiz on this section, just an assignment. We'll just have a unit quiz for this unit. Okay, see you later, guys.